What if the largest planet in our solar system is slowly changing? Astronomers have been watching Jupiter for centuries, but in the last few decades, something strange has started happening. Its storms are shifting. Its famous red spot is shrinking. Its atmosphere is behaving in ways scientists never expected. And every year, Jupiter seems to get weirder. Jupiter is the king of planets. It's so massive that more than twice the mass of all other planets combined is packed inside this single gas giant. But Jupiter isn't just big, it's chaotic, violent, and constantly changing. In fact, recent discoveries from spacecraft and telescopes are revealing that Jupiter is far more mysterious than we once believed. And the deeper we look, the stranger it becomes. Unlike Earth, Jupiter doesn't have a solid surface. Instead, it's made mostly of swirling gases like hydrogen and helium. Its atmosphere is a giant ocean of storms. Some of these storms are so big they could swallow Earth whole. But what makes Jupiter unusual is how fast everything moves. The planet spins incredibly quickly. A full rotation takes only about 10 hours. That rapid spin creates powerful jet streams that stretch across the entire planet. These streams form the colorful bands we see when we look at Jupiter through telescopes. But recently, scientists noticed something strange. These bands are changing shape and intensity over time, and no one is completely sure why. Perhaps the most famous feature on Jupiter is the Great Red Spot. It's a gigantic storm that has been raging for more than 300 years. To give you an idea of its size, at one time, 3 Earths could fit inside it. But here's the weird part. The storm is shrinking. Observations from the Hubble Space Telescope and the Juno spacecraft show that the red spot has been slowly getting smaller. Not only that, its shape has been changing. Scientists have even seen pieces of the storm breaking off and drifting away. Some researchers think the storm may eventually disappear. Others believe it could transform into something completely different. Either way, Jupiter is clearly evolving. Lightning on Jupiter is another mystery. For decades, scientists believed lightning on Jupiter only happened near the equator. But when the Juno spacecraft arrived in 2016, it revealed something surprising. Most of Jupiter's lightning actually occurs near the poles. That's the opposite of Earth. Even stranger, Jupiter produces a type of lightning known as shallow lightning. These flashes happen high in the atmosphere where temperatures are extremely cold. On Earth, lightning requires warm clouds, but Jupiter somehow generates powerful electrical storms in freezing conditions. Scientists are still trying to understand how this is possible. Jupiter also has the most powerful auroras in the solar system. On Earth, auroras appear as beautiful northern and southern lights. But Jupiter's auroras are on an entirely different level. They are hundreds of times more energetic. These glowing lights are fueled by Jupiter's enormous magnetic field, the strongest of any planet in the solar system. In fact, Jupiter's magnetic field is so large that it could swallow the sun if it were visible to the naked eye. And the weirdest part? The auroras on Jupiter never turn off. They are constantly glowing, powered by charged particles from Jupiter's volcanic moon, Io. This creates a cosmic feedback loop between the planet and its moon, something we don't see anywhere else. For years, scientists believed Jupiter had a small rocky core, but new data from the Juno spacecraft suggests something far stranger. Jupiter may have a fuzzy core. Instead of a solid center, the planet's core could be a massive, diluted mixture of rock, metal, and gas. Imagine a planet where the boundaries between layers are blurred, where the core slowly blends into the atmosphere above it. This discovery has forced scientists to rethink how giant planets form, and it might mean Jupiter had a violent past, possibly colliding with another massive object billions of years ago. Jupiter's storms are becoming another major focus of research. Massive cyclones swirl around the planet's poles. Some of them are arranged in perfect geometric patterns. For example, 8 giant storms circle the North Pole like petals on a flower. And these storms have remained stable for years. No one fully understands how such a structure can survive in such a chaotic atmosphere. But it's another reminder that Jupiter behaves in ways we're only beginning to understand.